Hello everyone, welcome you back for the fourth module in Smart Material. That is nothing but the MEMS piezoelectric sensing and actuation. MEMS is nothing but micro electromechanical systems. The piezoelectric sensing, the another part what we are discussing is nothing but the actuation which is done by using the magnetic material. Now here the fourth module consists of the MEMS. In that what all the things what we are discussing is the history of the MEMS, the intrinsic characteristics, microfabrications, photolithography, thermal oxidation, thin film deposition, etching, doping, dicing, bonding, microelectronic fabrication process, silicon based processing, and as a selection and design. The piezoelectric sensing and actuation. Now here in this the introduction with respect to the piezoelectric sensing, the actuations, the cantilevers piezoelectric actuator model, the properties of the piezoelectric material, applications, magnetic actuations, concepts, principles, and magnetization, and nomenclatures, and fabrication and case studies. See, this put together is nothing but the fourth module. Now here the first thing is what we are discussing in this is what is MEMS. As you know that the MEMS is nothing but a micro electromechanical systems. It's nothing but a technique or combination of the electrical and as well as the mechanical component together to form a chip, and the produced system is in the miniaturization of in dimension. As the name itself is suggesting, it has a MEMS, the micro electromechanical system. As the systems, or it may be the component which has been designed or the fabricated is in the form of a micro, but there it consists of the three things. Two things. One is the electrical, the another one is a mechanical component. Now the MEMS is integration of number of micro components on a single chip, which allows a microsystem to both senses controls the environment. Now the components are integrated on a single chip using a microfabrication techniques. See, this is put together is nothing but the MEMS. The micro electromechanical systems or the miniature systems presents our everyday lives. They are manufactured from a variety of materials, that too especially the manufacturing methods, and also the materials, either it may be a semiconductors or it may be a plastic or ceramics or the ferroelectric materials, magnetic materials, or even the biomaterials also. The MEMS are used as sensors, actuators, accelerators, switches, and even the light reflectors. Just the namings a few applications. The MEMS are currently uses in the automobiles, aerospace technology, biomedical application, inkjet printers, wireless, and optical communications. These are all the application areas where the MEMS is having a major growth. Now the new applications are emerging on every day with respect to the MEMS components, the ranging with respect to the size of a millionth of a meter, which is nothing but a micrometer, to a thousandth of a meter, which is nothing but a millimeter. They are also referred as a micro machines or a microsystems, or even a micromechanics or a microsystem technology. See, this technology it's not a very huge in size. This components what it has been fabricated is in microns. For that reason only it is called as the micro electromechanical systems. The size, which is a parameter, is varying from a micrometer to a millimeter. Now here in this sketch, which consists of the what we can say the IC. The IC is placed on a board, which is nothing but a printed circuit board. The entire IC is not what we can say a one operation or one operating device. It is an integrated circuit where the entire circuit is integrated. Now here in the block diagram, if you consider with respect to the block diagram, here the MEMS sensors are there, the electronics is there, communication is there. To have a communication and also to have a actuation, we need the power. The power is a main source, which is an essential parameter in the case of the MEMS to actuate or to sense or to communicate. Next, along with these two, to have an interaction, we need a software or some communicating media or a communicating device. Then the entire, what we can say, the actuation, what it is taking place is nothing but a MEMS actuation. See, this is a what we can say the basic concept with respect to the MEMS. Now here, in general, what we can say, it is a combination of either a microelectronic or a microstructure, and also what we can say a microsensors and a microactuator. Put together is nothing but what we can say the MEMS. The interaction between either it may be a sensors, or it may be actuators, or it may be a structure, or it may be electronics, that put together is nothing but a MEMS. Next, as you know that the four terms what we are using is nothing but the sensors, the actuators, and also the sensors, actuators, and also the structures and electronics. See, here the transducer. The transducer is a device that transforms one form of signal energy into another form. The term transducer can therefore be used, includes both sensors and as well as the actuators, and most generic and as well as widely used in the MEMS. The actuators. An actuator is a device that converts an electrical signal into an action, or it may be an actuation. It can be create either it may be in the form of a force, or it may be in the form of a torque, or it may be in the form of an instinct, or it may be in the form of an impact, or other mechanical devices or surrounding environment to perform some useful function. With respect to the application, today the MEMS is having a wide range of application, but it is not only in a particular field, it is in all the field it has been occupied. Now, the term MEMS generally referred to a microscale components or a macro scale devices within the systems, not entire system itself. In this sense, the name MEMS is somewhat misleading, as by using this statement, it is nothing but micro electromechanical system. As the name, it is suggesting it that it's a micro. The entire, what we can say, the system, it should not be a micro, but the, what we can say, the actuators, or it may be the transducer, or it may be the sensors, or the devices, or the ICs what we are using, it is in the form in the micros, in the order of micros, by which the entire component or the product, it comes under the category of the MEMS. But if you take the entire component itself, it's not as a MEMS. In order to create a completely functioning system that makes the use of the MEMS, the system will require various other subsystems, such as the powers, a microelectronics, or it may be communication, or it may be a software. These comes under the category of the micros. For that reason only, this entire thing can be have a concept of MEMS. Next, coming to the application. See, the application of the MEMS, it is not only with respect to the one sector, either it may be an automotive sector, or it may be electronic sector, or it may be medical sector, or a communication, or a defense. In all the fields, the application of the MEMS has grown like anything. If you take an example of the, what we can say, the medical field, the blood pressure sensor. The blood pressure sensor is a one best examples. The another one is the implanted pressure sensor. See, here in this case, what will happen? They are implanting the sensor in the human body itself, by which automatically we can find out the blood pressure, what and how much it is. Depending upon that, we can go for the medications. Now, the another thing is with respect to the electronics, the disk drive heads. As we know that the disk, it is the floppy disk, or it may be a compact disk, or even with respect to the, what we can say, the memory chips, what we are using it there, the size and as well as the storage of the data, it will be a vast. Then coming into the defense, where the surveillance, or it may be normally a something like a spy devices, by which where you will get information of the surrounding. See, these are all the major applications where the MEMS is occupied, and it is growing in further also. But the next thing what we are discussing is how small the MEMS are. See here, there is a comparison between what we can say the MEMS technology and also nanotechnology. See here, in this case, a 1 mm to 1 nanometer, the variation is a 1 mm to a 1 micrometer. That technology is nothing but the MEMS. The 100 nanometer to a 1 nanometer, where that technology is nothing but a nanotechnological concept. 1 nanometer to 100 nanometer is nothing but a nanotechnological concept, where the atoms, virus, proteins, and as well as the UV light lies. Now here, coming to the what we can say, in the case of the MEMS, where the human hair, the cells, and as well as the infrared light rays lying in between what we can say the 1 millimeter to 1 micrometer, ranging it. This technology is ranging in this region only. The components and also the devices which is lying in this range comes under the category of the MEMS